Okay, let's start. So, we were doing some examples based on uniform convergence of sequence of functions. So, I had done the uniform convergence of x to the power n. So, it is uniformly convergent on any interval of the form 0k, but is not uniform convergence on this interval, right? So today I'll take another example. So there are so many examples given in your book. You may just try that out. I'm taking another example that is not in your book. So question number 2 that I'm doing. So I asked you to do x by n. But x by n will be uniformly convergent in any interval of the form 0 to k. And k is any positive number. You just do that. And I'm doing the next question is this. Show that the sequence this sequence f of x fn x y x fn, this sequence fn where fn is what fn x is n by x plus n for x greater or equals to 0. Prove that this is uniformly convergent in any finite interval. That means you give me any finite interval, suppose 2 to 10, 0 to 100 and so on. This will be uniformly convergent on that interval. But it will be not uniformly convergent in infinite interval. Like from 0 to infinity, this will not be uniformly convergent. We'll see why. So this is the question. The sequence of function is n by x plus n. The first task being find the pointwise limit. That is your first task, definitely. So let help me to find the pointwise convergence. It's very simple. That means I have to find this fx, which is the pointwise limit. This is actually limit n tends to infinity fn x. So for any x greater or equals to 0, we have to find this limit. Okay, that means limit n tends to infinity, it is n by x plus n. Remember, x is fixed. For different values of x, you have to find this limit. Getting my point? How will you solve this? Divide by n. So this will become 1 by x by n plus 1. Right? Getting my point or no? And now you see, whatever x you choose, x is greater or equal to 0. You choose x as 0, 5, 10, 100, 2.5, 2.9. Whatever x you choose, this number is going to 0 as n tends to infinity. So this limit is nothing but 1. Therefore, the sequence of function fn converges pointwise to f of x equals to 1 for all x greater or equals to 0. Okay, so the pointwise limit is 1. Another way of writing this is or fn converges to f pointwise. And what is f? F is 1. So whatever x you choose, fn x is converging to 1. Clear? So definitely this is your first task to find the pointwise limit. Once we are done with the pointwise limit, then I can talk about the uniform convergence. Go through it once, then I'll start with the uniform convergence. Now about the uniform convergence. If you remember the definition of uniform convergence, just a minute, where I had given, yeah. So this was the definition. That means fnx minus fx should be less than epsilon for all n greater or equals to m. There should exist a natural number n for all x in d. So for all x in d, you have to find a natural number for which such that for all natural numbers greater than that, this relation will hold. So we have to find that natural number m. So very simple. So this is the first thing. So let epsilon greater than 0. You have to choose any epsilon positive. So let epsilon greater than 0 be given. So we have to find fnx minus fx. So for, let me do for a case when x is positive. For 0 we will deal that differently, okay? So for x greater than 0, modulus of fnx minus fx, what is this? I am taking this as less than epsilon. So if this is less than epsilon, that will imply, what is fnx? It was n by x plus n minus fx being 1. This is less than epsilon, right? Simplify this. This is n minus x minus n by x plus n. This is less than epsilon. N got cancelled. Modulus of minus x is x because x is positive, and x plus n is always positive. So this is the case. So this is less than epsilon. Sorry. Yeah. So this quantity will be less than epsilon when this holds, or in other words, when this holds. Getting my point? So from here, you have to determine n. For what value of n this will be less than epsilon? Let's see. Okay. So firstly, I will reciprocate. I'll reciprocate both sides. So this will become what? If I am reciprocating, so let me write down the last line again. What was the last line? X by x plus n, x by x plus n less than epsilon. This was the last line, right? So this was the last line. Just a minute. Yes. So this was the last line. So how will you solve for n from here? Reciprocate both sides. This by x will become more than 1 by epsilon. Splitting up, so x by x is 1 plus n by x greater than 1 by epsilon, and that will imply n by x greater than 1 by epsilon minus 1, or n greater than x times 1 by epsilon minus 1. Any confusion up to here? See, now if we consider an infinite interval, that means from 0 to infinity or something like that, any interval at infinite length, then as x approaches infinity, this also will approach infinity. So you cannot find a natural number which is greater than this number if the interval is of infinite length. Okay, so we will consider, we have to show in a finite interval that it is uniformly convergent in any finite interval. So if you are considering an infinite interval, then as x approaches infinity, you cannot find a natural number more than this number. Not possible. Okay, so that is the reason they are talking about finite interval. So I'll talk about finite interval. So therefore, for x greater than 0, I'll write that later on. So this was for x greater than 0, but we have to do for 0 also. For x equals to 0, let's find fnx minus fx. So because what we have done, this was for only greater than 0. For 0, let's see what happens. So what is fn0? It is n by 0 plus n. N got cancelled. Fn0 is always 1. Minus fx is 1. So this is 0, which is less than epsilon for all n greater or equals to 1. So at 0, any natural number will work. This is true for any natural number more than 1. So it will be true for any natural number more than 2, more than 3, more than 10, more than 100. That will work. Getting my point? So let's combine this case. But we have to first take an interval of finite length. So if we consider an interval 0 to a, where a is greater than 0, if you consider a interval, this is a finite interval definitely, so a finite interval, then can you tell me what is the maximum value of this quantity then? In this interval, what is the maximum value of this quantity? What is the maximum value of this quantity? You see, this increases with x. You increase the value of x, this quantity will increase. So now you see, this x lies here. So what is the highest value of x, which will be a? So then the maximum value of x 1 by epsilon minus 1 is a 1 by epsilon minus 1. Did not get? My point, if you are choosing epsilon very close to 0, suppose 0.1, if epsilon is 0.1, what will be 1 by 0.1? That will be 10. So 10 minus 1, this is a positive quantity. If you are choosing epsilon very close to 0, this number is always going to be positive. However, if you are choosing epsilon equals to suppose 2, if you are choosing epsilon equals to 2, then this quantity is what? Negative. So this will become n greater than minus x. In this case, we don't have any problem because every natural number is greater than a negative number. So in that case, if epsilon is more than 1, so this quantity becomes negative. So any natural number will work. I will take n equals to 1. That will also work. So we are not very much interested here because in this case the problem is already solved. But what if epsilon is very close to 0? Then in that case this is always positive. So this increases as x increases. So what is the highest value? The highest value will be this. Now it is clear. So this relation will be true if I choose any natural number which is bigger than this, because the highest value that this can take is this one, right? So if I choose any natural number which is more than this, my task will be done. So choose, or let me write, let m be box of this number plus 1. So that makes m an integer or natural number, because this is positive. Choose m. No, writing this will be wrong because this may be negative, no? So no, writing this will be wrong because in some cases this may be negative. So choose m belonging to n such that m is greater than this quantity, right? M is greater than this quantity. if I choose a natural number which is greater than this quantity, then modulus of fn x minus fx is less than epsilon, then for all x greater or equals to 0, this is less than epsilon for all n greater or equals to m. So therefore fn converges to f uniformly on 0 to a. Again I'll explain it to you, don't worry, but you first copy this down and again give you a quick recapitulation what I did here. Firstly, I calculated the pointwise limit. The pointwise limit is 1. So that's all. Now to verify whether it is uniformly continuous or not, what I have to do, I have to for any given epsilon, I have to find a natural number for which this relation holds for whatever x you choose. That means that natural number should be independent of the point. Then only we say this will be uniformly continuous. So my aim is to find a natural number for which this relation will hold independent of x. So I have taken the case of 0 differently, because for 0 it is very simple. When the point is 0, fn0 is 1, fx is also 1. Modulus of 1 minus 1 is 0. So this will be true for any natural number. This relation holds for any natural number. If you choose n as 1, this will be true. If you choose n as 2, this will be true. So we don't have any problem for choosing a natural number at 0. Okay. Now, if x is more than 0, that is positive, I am checking when will this relation hold. On simplification, I am getting that this relation will hold when n is greater than this. But you see, the choice depends upon the value of x. So I have to make this independent. How will I do that? If I am choosing an infinite interval, that means an interval of infinite length, then this number gets bigger and bigger. Because if x tends to infinity, this gets bigger and bigger. See, if this quantity is negative, like suppose if you are choosing epsilon as 2, then this quantity is negative. In that case, n greater than a negative number, any natural number will work. Right? Because every natural number is more than a negative number. So that is the reason we are not interested in this case, because this case is very trivial. We are interested in the case where epsilon is very close to 0. That means epsilon is greater than 0 and less than 1. We are interested in that case. In that case, this number is positive. As x increases, this tends to infinity. So it is not possible to find a natural number more than infinity. Kind of that. Okay. So that is the reason this will not be uniformly continuous in an interval of infinite length. However, if I consider a finite interval of this form, the maximum value that this quantity can take is this, a times this. Now, so any natural number which is more than this, then this will be satisfied. So I am choosing a natural number such that that natural number is just more than this quantity. So this relation along with this one, for 0 also I have to consider. For 0 this is true for every natural number, so I can choose m also here. So that this relation holds for all n greater or equals to m, and you see this m does not depend upon the point that I am choosing. This m has no x in it. So we can say that this is uniformly convergent on this one. Got my point? If you remember, we used to do so many tests in sequence and series, no? that there was a test. Using this test, the D'Alembert's ratio test, with that test you can easily say whether a series is convergent or divergent. So similarly, we have a test for uniform convergence. So let me write that test. So this is the test for uniform convergence. Test for uniform convergence. This test is called as MN test. MN test. So what is the test? Let Fn be a sequence of functions on some interval I am talking about some interval, okay, where I have to check the uniform convergence, such that limit n tends to infinity fn x is fx for all x in I. That means you have to first find the pointwise limit. That is what they are saying, such that the pointwise limit is fx. The pointwise limit is fx. So I have a sequence of functions. I have to check the uniform convergence on I, and the pointwise limit on I is fx. Then the test says this. Then Fn converges uniformly on I, if and only if. So this is a very strong thing because it gives you necessary and sufficient condition. If and only if limit n tends to infinity, Mn is 0. What is Mn? Where Mn equals to supremum of modulus fnx minus fx, and the supremum is taken over x in I. I will explain it to you. So you try to understand what this test says. The test is something like this. You have a sequence of functions, and this sequence of function converges pointwise to fx on I. Okay, this converges to fx pointwise on the given interval I. You define this quantity Mn. So M will be a function of n. It will depend on n. You will take the supremum of these numbers. So you take whatever values of x you want and see the highest value here. Okay, it will be in the highest value will be independent of x, but will depend on n. This n, you call that as Mn. Getting my point? So then this sequence of function converges uniformly on I, if and only if limit n tends to infinity, Mn is going to be 0. For example, I'll do questions in the next class, but I'll just give you a basic idea. Suppose for some sequence of function fn, this is sequence of function, okay, suppose the pointwise limit is 0. I'm just giving a very random example. So fx equals to 0 for some x over some interval I. Okay, you calculated Mn. Mn will be what? Supremum of x in I fnx minus fx. Fx is 0. That means you have to find the supremum of fnx x in I. On calculating this, I'll teach you the calculations in the next class. Suppose you are getting 1 by n. You are getting the supremum as 1 by n. That is, what is Mn? Mn is 1 by n. Limit n tends to infinity, Mn is 0. So this has been achieved. So what can I say? Fn converges uniformly on I. Did you get the use of this test? Yeah. So in the next class, I'll teach you how to find this maximum value, supremum value. So you see, what's the nice thing about this test? It does not involve the calculation of finding that natural number m, that is so confusing. It just tells you to find this supremum, and this is a sequence. You see, this is a sequence. So now to test the uniform convergence, you have to just check the convergence of this sequence. If this sequence converges to 0, we say that will be uniformly convergent. If it converges to any other number, that will not be uniformly convergent. So this will be MN test. Based on the MN test, I will do some sums in the next class. So